a particle moves in a one-dimensional potential that is given here, where k of t is a time-dependent parameter. So the force constant for the potential k is a time-dependent parameter. Now we're asked to find the rate of change of the expectation value of v. So dv by dt. So the any operator, how it commutes with the Hamiltonian gives its time dependence. Okay, so how the changes over time is given by operator A. How it changes over time is given by how it commutes with the Hamiltonian and its partial derivative with respect to time. So here we have the parameter v. We have to calculate how it changes with the time. So it's how it commutes with the it's given by how it commutes with the Hamiltonian and its partial derivative with respect to time. Now the Hamiltonian is nothing but p square by 2m plus the potential term half kt, so half k x square, so where k is a time dependent parameter. Now p and x both are operators, that's why they have these hats. So now let's substitute this Hamiltonian in this equation and the value of v in this equation. So v, when substituted, v is nothing but half k x square, so that is substituted here, and the Hamiltonian, so the Hamiltonian that is supposed to be here, it is substituted here, and then we have the this term. So v is, this is what v is, so v is substituted here. Now what I'm doing is I'm just factoring out all the common terms. So here there should also be a 2 here. So I'm just factoring out all the common terms and I'm collecting all the operators inside the bracket. Now, and here also we are only the k term has time dependence, so we only the k should be taken the time derivative. So that is what I'm collecting out here and factoring out the common terms that don't have time dependence. Now this bracket, notice, can be written out this way. So just expanded the bracket here. So x square, so this is your commutator. So a commutator can be a commutator is expanded out this way, right? So this is your commutator, x square p square. This is your commutator. So this is how the commutator is expanded. Now notice this is in the form a square minus b square, and this is can be written out this way. So notice what this is. Xp minus px is nothing but your is your x comma p commutator, which is nothing but 2 times I h bar. Okay, so this term just becomes 2 times I h bar. Okay, so this is nothing but xp minus px. So this expression then just simplifies to this expression now just simplifies to kt by 4I h bar m into 2 times I h bar. This comes from the commutator of x comma p, so px xp minus px, and the remaining term xp plus px plus half times dk by dt and x square. So notice all these things are actually operators still, right? So what you would get as a result would be nothing but, so this term, first term becomes k, which is k by 2m, and this, so these just cancel out, and this operator, when it acts, it will give the expectation value, right? So k by 2m, and this operator, when it acts, it gives the expectation value of xp plus px, and then I have half dk by dt, and this is a operator, so when it acts it will give the expectation value of x square. So this is how, this is nothing but your answer for how the expectation value of v changes over time. So the right option here is given by the option